Alright, so I want to talk about the inverse cosine function, also known as Arccosine, and sometimes denoted as um, like cosine with this -1, like that. I think that's misleading, so if you can avoid using that, please do. I like to call it Arccosine or inverse cosine. Arc sounds cool to me, so I like that name better. But let's just review what cosine is in the first place. So we're dealing with trigonometry, and that's really just about the relationship between angles in a right triangle and the ratio of the sides with respect to that angle. So, for example, cosine of an angle is simply the ratio of the side length of the side of the triangle that is adjacent to it, the one it's next to that's not the hypotenuse, um, over the hypotenuse. So if the adjacent side length here had a length of 4 units and the hypotenuse 5, then the cosine of theta would be 4 over 5. That's it. All right, so that's cosine. It's just a ratio. Um, and okay, so then let's talk about inverse cosine. But first, what is just an inverse function in general? Um, And here I've got a little example that I like to use. It's just very simple. The square function and square root function are inverses of each other. So if I take 5 squared, what is that? That's 25. Well, that means that if I take the square root of 25, I get 5. So you see how we started with 5 and we ended up with 5? The the square root function and square functions are inverses of each other. So this should look more like a 5. Alright, so if I, so okay, so let me kind of connect it to cosine. So if we have cosine of some angle, um, let's say, alright, let me just, instead of saying some angle, let me say cosine of 30 degrees. Cosine of 30 degrees is, so if this were a 30-degree angle, the kind of triangle that would result would make it so that the cosine is the ratio of the square root of 3 over 2. And I have this little chart of just common trig ratios for for these standard angles, 0, 30, 45, 60, 90. Um, those are good ones to memorize, and you'll see these on the unit circle. If you see them on a unit circle, the patterns become clear and they're much easier to memorize. But that's for another day. Anyway, so the cosine of a 30-degree angle would be the ratio square root of 3 over 2. Well, that means that the arc cosine of square root of 3 over 2 would be 30 degrees. So kind of analogous situation here. We started with 30 degrees, turned into this ratio, and then, sorry, I don't know what that was. Turned into this ratio by applying the cosine function to it. Then we did the arc cosine function, which undoes that, and we end up back at 30 degrees. All right, good. So let's try some examples. Again, I have this chart here of common trig ratios, so we can make use of that for a couple of these, and then you can always use your calculator too. Should have a arc cosine function. So here on my calculator, I've got cosine and then a cosine, arc cosine there. So actually, let me switch it to degree mode. Okay, so we want to know what this angle is. Okay. Well, what information can we use to figure out what that angle is? Oh, I guess I should note that these are right triangles. These are all right triangles. Okay, so what do we know about this angle? Well, we know the side lengths of two sides that are very related to it. One is the adjacent side, and one is the hypotenuse of the triangle. So that we've got this ratio of 1 to 2. So what's the ratio of the adjacent side to the hypotenuse? Well, that's called the cosine of theta. So the cosine of theta is 1/2. So let's look at that. Here we go. Cosine 1/2. Well, what angle produces a cosine of 1/2? 60 degrees. So arccosine of 1/2 is equal to 60 degrees, because cosine of 60 degrees is equal to 1/2. Alright, let's try another one. So what about this this triangle here? Again, we have an unknown angle, but we do know a couple side lengths of the triangle. The side that's adjacent to this angle is 3, and the hypotenuse is 6. So the ratio of the adjacent to the hypotenuse is the cosine. So the cosine of this other theta is the ratio 3 to 6. 3 to 6. Arccosine of 3 to 6 is what? Well, I don't have that on my chart. There's no ratio of 3, 6. But I don't need to start running for my calculator just yet. Why don't we just reduce this ratio? What is 3, 6 equivalent to? 3 out of 6 is the same as 1/2. So we can reduce that to 1/2. Well, what's arccosine of 1/2? 60 degrees. So the arccosine of 3, 6 is 60 degrees. In other words, this is a similar triangle to this one. These two are similar triangles. It so happens the side lengths of this triangle are all 3 times the side lengths of this one. Alright, is this kind of making sense so far? So let's try another one. I was kind of boring and put the angle that we want to find all in the lower right corner of the triangle. We could have done this a lot of different ways. In fact, I did kind of mix it up for you in your little practice problems down here. So, okay, so we've got the adjacent side and the hypotenuse, and of course, we could use the Pythagorean theorem to figure out the opposite side too, if for some reason you prefer to deal with sine rather than cosine. But say like we're only given this information. The cosine of theta, in this case, is the ratio of the adjacent to the hypotenuse. So 9 to 11. So what's the arccosine of 9 11? What angle gives us a cosine of 9 elevenths? Well, that is not on our chart. And can we reduce this ratio further into some ratio like one of these? No. So, alright, so let's just grab our calculator. So we do arccosine of 9 elevenths, like that. I have my calculator in degrees mode, so it'll tell me the angle in degrees rather than radians. You can switch to, I don't know, if you need the angle in radians, that's fine. I want it in degrees. That's what we've been doing. So about 35 degrees. 35 and some change. So that angle is about 35 degrees. I think. Yeah. Alright. Good. Well, here's some practice problems for you. Don't be alarmed by this decimal. Just remember that fractions and decimals, you can convert between them, and you don't even need to convert between them. Just, I didn't have to say arccosine of 9/11ths. What is 9/11ths? That's 0.8181 repeating. So I could say arccosine of 0.8181, about 35. Yeah, so go through those and reduce stuff if you need to. And yeah, that's it. So good luck.